Hello, I'm Anna Mackay and this video is on the derivatives of logarithmic functions. So here are our rules. Reminder for my students, make sure you're writing all of this down into your notebook. If we have the function ln x, now ln is a log with, it's a natural log with base e, then the derivative is nice and simply 1 on x. If we have ln f of x, so some form of a function, you differentiate the function, not derive, you differentiate over the function. So for every time you differentiate a log function, the log or the natural log disappears. You'll also need to be pretty quick and smart using your log laws. So here's a reminder of what they are. Log or natural log, AB, you can split that, ln A plus ln B, ln A on B, split that, ln A take ln B. Oh, again, a simple way to remember that, might seem a bit lame, is that the divide sign looks a bit like a subtract sign, and if you've got two functions being multiplied, multiplication is a bit like an addition turned on its side, and hence the addition there, if you're stuck on how to remember which rule to do. Also with logs, if you've got ln A to the power of n, you can bring that n down out the front. And when you're dealing with e's, e to the power of ln A is just a, and ln to the power, e to the power of n is just n. They'll come in handy. So let's do some examples. Find the gradient function, and gradient function is asking you to differentiate to find the derivative of y equals ln 2x plus 3. So we need to find dy by dx. Let's write that. Dy by dx is equal to, I've put the rules down here, the ones that are going to be handy. So this is ln of a function, so you differentiate that function. The derivative of just that bit there would be what? 2 over the function, so 2x plus 3, and we leave it there. That's all we need to do. Over here, find the derivative of this. Well, first of all, that's two functions together. So we're going to have to use the product rule on this one. So finding dy by dx, so differentiate the first, leave the second. The derivative of x cubed is 3x squared, leave the second function, and add on where you leave the first function and differentiate the second. And the derivative of ln x is just simply 1 on x. Oops, 1 on x. Let's tidy that up for good practice. Just referring to the last part, x squared. So moving on, here we have y equals ln square root of x squared plus 3. Now, a little bit trickier there. There's a function and then that function is raised to the power of a half. Let's use our log laws first to simplify that. Looking at this log here, this log law here, let's rewrite this function with a fractional power instead, to the power of a half, and use the law where we bring the power down out the front. So that is a half ln x squared plus 3. Now we can go ahead and differentiate. So dy by dx, we will leave the half there, and as previous rules tell us, you differentiate this part, it'll be a fraction. We put a times there, we get 2x over the function, and let's simplify that slightly, tidy up those 2's, x squared plus 3. So x over x squared plus 3. Next one, this is ln x cubed times by e to the x. So that's two functions. We're going to have to use our log laws first to simplify that. Two functions multiplied together, we can split them with our log laws. So y equals ln x cubed plus ln e to the x. A couple more log laws we can use. So for this, pull the power down out the front, 3 ln x. And for this one here, again, let's pull the power down out the front. If you are more comfortable jumping ahead with some of the rules there, that's fine. That's as simplified as far as we can go, but ln e, feel free to use your calculator to check that if you can't remember, is just 1. So we just have x there. Now we differentiate. So now is when you go put down dy by dx. Don't just keep writing equals down the line there. This is when you differentiate and apply the rules. So differentiating ln x is just 1 on x, but we can write 3 on x. And the derivative of x is just 1. Moving on. Again, a more complicated ln function here. We're going to have to use log laws first, so always be on the lookout for that. Using this one here, feel free to pause this video and try it yourself. I'll assume you've done that. So splitting the log here, ln x squared, take away ln, please use brackets, 2x take 1. Simplifying a little bit further here, ln x, so 2 ln x, and then ln 2x take 1. Now we can differentiate. So feel free, pause the video and try it yourself. I'll assume you have. So the derivative would be 2 on x, take away, you differentiate the function in there to get 2 over the function. So 2x over 2 on x take 2 on 2x take 1. Now, a bit more of an applied question. Find the gradient of the tangent to this y function at x equals 2. So whenever you get asked to find the gradient of the tangent, you need to differentiate. Again, a bit complicated, use your log laws. So do that first step, simplifying y, pause the video and try that. I'll assume you have, I've got it over here. So ln, just double checking, x plus 2 all cubed minus ln x, and pull that power down out the front. So there is our function, and now we need to differentiate. Pause the video, try it yourself. And here's our derivative. So 3 by the derivative of this bracket here, which is 1 on the bracket. And the derivative of ln x is 1 on x. Tidy that up just a little. Perhaps I'll just put it off to the side here. Just bring that 3 in. Now we're not finished. We need to find it at x is equal to 2. This is the point where using function notation is handier than the y function notation. So sometimes I just like to write that that's equivalent to f dashed of x. And now I'm going to continue on with function notation. So we have f dashed of 2. So finding the gradient of the tangent at x equal to 2. So substituting in a 2 where you see an x. Now, this is good practice if you're not using a calculator. Good practice at fractions. 3/4 take a half is 1/4. So the gradient of the tangent to the y function at x equals 2 is 1/4. If you like this video, give it a thumbs up and subscribe to the channel, and the next video in this series is called Derivatives of Trigonometric Functions. Thank you.